Close your eyes for a moment. Picture the night sky. Not the sky you see from a city, washed out by light, but a deep, primordial sky, a velvet canvas, impossibly black and dusted with the diamond light of a billion stars. It feels eternal, doesn't it? Permanent. But what if I told you that this view is a quiet illusion, that the universe we see today is emptier than it once was? What if billions upon billions of entire galaxies, once shining brightly in the cosmic dawn, have simply vanished? This is not science fiction. It is one of the most profound and beautiful mysteries in all of cosmology, the faint blue galaxy problem. In our journey tonight, we will not be solving a crime, but rather unraveling a ghost story written across the fabric of space-time itself. So take a deep breath and let the quiet darkness of space be your guide as we ask the question, where did they all go? Our story begins with a simple yet powerful idea. In cosmology, looking far away is the same as looking back in time. Light, the fastest thing in the universe, still takes time to travel. The light from our sun takes 8 minutes to reach us, the light from the nearest star over 4 years, and the light from the most distant galaxies can take billions of years to complete its journey. So when we point a powerful telescope at a distant corner of the cosmos, we are not seeing it as it is today. We are seeing it as it was when the universe was young. We are, in effect, cosmic archaeologists. And in the 1990s, humanity unveiled its greatest tool for this archaeology, the Hubble Space Telescope. Floating above the distorting haze of Earth's atmosphere, Hubble could stare into the abyss with unparalleled clarity. Astronomers decided to conduct a bold experiment. They pointed Hubble at a tiny, seemingly empty patch of sky in the constellation Ursa Major, a sliver of darkness no bigger than a grain of sand held at arm's length. For 10 straight days, Hubble gathered every faint photon it could. What it sent back changed our understanding of the universe forever. The image, now famously known as the Hubble Deep Field, was not empty at all. It was overflowing with life. Nearly 3,000 individual galaxies, each one a swirling island of billions of stars, were captured in that single, tiny frame. But among the familiar spirals and grand ellipticals, there was something strange. A swarm of faint, small, bluish smudges, more of them than anyone had ever predicted. These were the faint blue galaxies, and they were the first clue that the universe's past was far more crowded and far more chaotic than its present. So, what exactly were these celestial ghosts that Hubble had uncovered? Let's paint a picture. Imagine a grand modern city like Tokyo or New York. It has well-defined structures, established highways, and a certain majestic order to its sprawl. This is like a modern, mature galaxy, the kind we see in our cosmic neighborhood. Now imagine a chaotic, sprawling boomtown from a bygone era, a place of frantic construction with small, makeshift buildings popping up everywhere, dust in the air and a raw, untamed energy. This was the nature of the faint blue galaxies. They were not the grand, well-ordered spirals we know and love. Instead, they were small, clumpy, and irregular in shape, like fragments of some larger design that had not yet come together. They were cosmic toddlers, full of energy but lacking the grace and structure of adulthood. Their defining characteristic, of course, was their color. That distinct, ethereal blue was a direct message from the past. It was the signature of brilliant, massive, and intensely hot young stars. These are the titans of the stellar world, stars that burn hundreds or even thousands of times brighter than our own sun. But their brilliance comes at a cost. They live fast and die young, exploding as magnificent supernovae after only a few million years. Their presence meant that these small galaxies were in a state of frenzied starbirth, a starburst of incredible intensity. They were cosmic nurseries on overdrive, converting vast clouds of primordial gas into new suns at a rate far exceeding that of our own Milky Way today. This was the first portrait of our universe's ancestors, small, chaotic, and burning with a brilliant, youthful fire. The sky was literally filled with them. And that's when the truly unsettling question arose. Visual idea, an animation showing a zoom-in on the Hubble Deep Field. As we get closer, individual galaxies resolve. The large, modern-looking spirals are highlighted, then the video focuses on the numerous, smaller, bluish smudges, making them glow to emphasize their number and color. Now we arrive at the heart of the paradox, the central mystery that baffled astronomers for years. It's a simple matter of cosmic accounting. When scientists counted the number of faint blue galaxies in the Hubble Deep Field and then extrapolated that number to the entire observable universe, they got a staggering figure. The numbers suggested that billions of years ago the universe contained significantly more galaxies than it does today. Let that sink in. It's a profound violation of our intuition and, more importantly, of the prevailing cosmological models. Our understanding of the universe is built on the idea of hierarchical structure formation. The theory posits that small things form first, and then, over eons, gravity pulls them together to form larger and larger things. Small star clusters merge into small galaxies merge into larger ones, and large galaxies cluster together into superclusters. The universe should be getting more structured and clumpy, but the total number of its fundamental building blocks shouldn't just decrease. It was as if you walked into a forest and found more saplings in the past than you find saplings and mature trees combined in the present. Where did all the wood go? This was the faint blue galaxies' problem. Did they just burn out like cosmic fireflies winking out one by one? This seemed unlikely. Even when their hot blue stars died, the smaller, longer-lasting stars and all the gas and dark matter should have remained. Did they explode? There is no known mechanism for an entire galaxy to self-destruct. Were they ripped apart by some unknown cosmic force? Every proposed solution seemed to create more problems than it solved. The universe appeared to have a case of disappearing galaxies, a cosmic crime scene with billions of victims and no suspects. The evidence was clear. The past was full of them, the present was not. The beautiful, logical, hierarchical model of the universe suddenly had a giant, galaxy-shaped hole in it. Visual idea, a simple, powerful animation. On the left side of the screen, a box labeled Early Universe is filled with hundreds of small blue dots. On the right, a box labeled Present Universe has only a few dozen large, spiral and elliptical shapes. An arrow points from left to right, with a giant glowing question mark over it. The numbers on screen could show something like 10 times more galaxies in the past, to emphasize the paradox. The solution to this grand cosmic mystery was not hiding in some exotic new physics. It was hidden in the very nature of the galaxies themselves, in their chaotic structure, and in that brilliant, telltale blue light. The key was to stop thinking of them as victims that disappeared and to start thinking of them as ingredients that were transformed. The intense blue color, as we've seen, pointed to rapid, unsustainable star formation. These galaxies were not built for the long haul. They were living fast, burning through their fuel reserves of cosmic gas with reckless abandon. At the same time, their small size and mass made them incredibly susceptible to the most powerful force in the cosmos, gravity. In the crowded environment of the young universe, these small galaxies were constantly interacting, their gravitational fields tugging and pulling at one another. They were not isolated islands, but participants in a relentless cosmic dance. And when dancers get too close, they merge. This is the heart of the merger theory. The faint blue galaxies didn't vanish, they collided, they merged, they became one. It was a process of cosmic cannibalism, or perhaps more poetically, cosmic consolidation. Over hundreds of millions of years, pairs, triplets, and whole groups of these small, fiery galaxies were drawn into gravitational embraces from which they could not escape. They would swirl around each other in beautiful, destructive ballets, stripping stars and gas from one another, their shapes distorting until finally they coalesced into a single, larger, and more massive entity. The ghost was not a ghost at all, it was a seed. Visual idea, a high-quality CGI simulation. We see 2 or 3 small, irregular blue galaxies on a collision course. As they approach, tidal streams of stars are pulled from them. They pass through each other, their structures disrupted. Over a sped-up timeline, we see them fall back together, their stars and gas mixing, until they settle into a single, larger, and slightly more organized galaxy. The intense blue color begins to temper with swirls of yellow and red as the star formation process stabilizes. This process of merging and growing wasn't a rare or isolated event, it was the primary way that large galaxies like our own Milky Way were built. The faint blue galaxies were the bricks and mortar of the modern universe. Each grand spiral we see today is not a single monolithic entity that sprang into existence fully formed. It is a composite, a mosaic, a megalopolis built from the ruins of countless smaller towns. The evidence of this violent, constructive past is written all over modern galaxies if you know where to look. When we study the outer reaches of our neighbor, the Andromeda Galaxy, we see vast, faint streams and halos of stars orbiting far from the main galactic disk. These are not native to Andromeda, they are the shredded remains of smaller galaxies that Andromeda consumed billions of years ago. Their stars continue to orbit their conqueror like ghosts, a silent testament to the merger that destroyed their home. Our own Milky Way is guilty of the same cannibalism. We are currently in the process of consuming several smaller dwarf galaxies, like the Sagittarius dwarf spheroidal galaxy, whose stars are being woven into the fabric of our own. The faint blue galaxies, therefore, are our ancestors. The very atoms in your body were forged inside stars that likely belong to one of these small, forgotten systems, which later merged to form the proto-Milky Way. They didn't go anywhere. They are right here. We are standing on their legacy. They are the forgotten multitudes that died so that the grand cathedrals of the cosmos could be built. Visual idea, an image of the majestic Andromeda Galaxy. Then superimpose faint, ghostly outlines and stellar streams around it, illustrating the remnants of consumed galaxies. The camera then pulls back to show our Milky Way, with a similar, fainter halo and a visual of a small, dwarf galaxy being tidally stripped as it merges with us. The final confirmation of this beautiful, elegant theory comes from the most powerful time machine ever built, the James Webb Space Telescope. With its incredible infrared vision, JWST can peer even deeper into the cosmic dawn than Hubble, seeing the universe's first galaxies with breathtaking clarity. And what it sees confirms the merger model completely. JWST's images show us a young universe teeming with these small, clumpy, actively forming galaxies. It can see them in even greater numbers and at even earlier times, catching them in the very act of interacting and merging. We are no longer just inferring the past, we are watching it happen. The faint blue galaxy problem has, in essence, been solved. It was never a problem of disappearing matter, but one of evolving identity. The universe did not lose its galaxies grew up. They traded their chaotic, fiery youth for a more stable, structured adulthood. That frantic blue glow of countless small systems was consolidated into the majestic, spiraling light of fewer but grander cosmic islands. The ghost story has found its ending, and it's a story of transformation, not loss. When you look at the night sky, you are seeing the result of this epic, multi-billion-year construction project. Each point of light, each galaxy, is a survivor, a conqueror, a testament to a past that was far more crowded, violent, and vibrant than the quiet peace we see today. The ghosts are all around us, not as specters, but as the very foundation upon which we stand. Visual idea, a dramatic transition from a classic Hubble Deep Field image to a new, stunningly sharp and detailed James Webb Deep Field. Zoom in on a region showing several small, distant red galaxies interacting, with clear signs of tidal tails and merging activity, providing a powerful visual confirmation of the theory. So, the great cosmic disappearance was, in the end, an illusion. The faint blue galaxies did not vanish into nothingness. They became everything we see around us, They were the seeds of cosmic forests, the building blocks of empires, the ancestors of our own galactic home. The solution to the paradox is as beautiful as it is profound. The universe is not a static collection of objects, but a dynamic, living system that evolves and changes. The past is never truly gone, it is simply absorbed into the present. Thank you for joining us on this journey through time to solve the mystery of the faint blue galaxies. The next time you gaze up at the vast, silent expanse, remember the chaotic and fiery youth of our universe. Remember that every great galaxy is a monument built from the ghosts of countless smaller ones. The cosmos is full of stories like this, waiting to be read in the light of distant stars. What cosmic mystery do you think we should explore next? Let us know your thoughts in the comments below. And until next time, keep looking up.